imagine I have to go and create threads. So should I be managing all the threads by myself? Because the examples which I gave you, I'm the one who is creating the thread. I'm the one who is ensuring the tasks are submitted. I'm the one who is managing their life cycle, whether it should be in the waiting or right, it should be in the execution or not. Okay. So we'll use concurrency API. So the Java has given actually concurrency API so that API will ensure that you are only worried about the writing the task which needs to be executed in parallel. Instead of worrying about managing the thread state, thread lifecycle, and so on, joining the threads and so on, you need to just focus on how do you get the multiple tasks executed. And for that, they have given something called as java.util.concurrent package, and they have provided something called as concurrency API. So what are those APIs? This is meant for handling complicated work of managing threads for you. So they handles the thread management part. You don't need to go and create your threads. All right. So for that, what they have given you is they have given you executor service interface. They have given you executor service interface. And what are the features? It provides you thread pooling. It provides you can do scheduling. And even if you need only a single thread, this is advisable to use the executor service. Advisable to service. All right. So just to summarize, java.util.concurrent package is provided by Java. What it gives you is that it handles the complicated work of managing the threads for you. And they just provide you the executor service interface. And these are the additional features, thread pooling and thread scheduling. Now, what exactly thread pooling is? Thread pooling is like you have created a pool of threads. Instead of creating one thread every time, you created, let's say, pool of threads and kept this pool of thread handy. All these threads are created and ready to receive the task. Any task that is submitted, some thread will get assigned and they will go start executing the task. They will start executing the task. Same, a new task is assigned, the next thread will be assigned, the same new thread task is getting, next thread will start executing. Now, what will happen after this? Once this task completes, this thread is again restored into the pool. So this thread does not get killed, it just gets back to its pool. What is the reason for it? Reason is creation or termination of thread is also a time-consuming process. So why to create and terminate every time? Keep those workers handy, keep those workers available. They will receive the task, they will go and do it. Once it is done, they will come back and ready to receive another task. And that's what the job of thread pool is. Now scheduling is, in all the examples that we saw today, what we did, we just kept on starting the task just now. What if I want to start a task every day or every week, Sunday, maybe 11 a.m.? What if I wanted to create a task that should run every day, Sunday, 11 a.m.? How would I do that? The answer to that is go and use the scheduler. You go and use the scheduler for that. All right. Clear? Now, let's take a look at it. How the executor service can be used. As I said, executor service is an interface. So how do we obtain an instance of it? How do we obtain the instance of it? So they have given the executors as a factory class. And what is the use of factory? Go and create new product. So it is responsible for creating the new single thread executor. And this is what, this is the factory method of the factory class executors. And it gives an object of type executor service. And now with the help of this service, I can go and execute the runnables. Okay. I can go and execute the runnables, keep the word and the method in mind. This is okay. This is the job of executor service interface. All right. Now let's see that in action. Okay. Let's see that in action. So what is the purpose of single thread executor? It's like, I don't need to go and create thread. I don't need to go and manage thread and so on. I'll just create an executor. I'll go and keep on executing the task, and it will ensure those tasks are executed. That's it. All right. Now, okay. So let's take a look at the command that is there. That is the execute, and it executes the task at some point in future. That's the job of runnable. Okay. It executes the task at some point in future, and it is also, that's why it is also known as fire and forget method. This execute is also called as fire and forget. Fire and forget as in, you submit the task and you forget it. It will ensure, executor service will ensure it gets executed sometimes in future. Let's see that in action. Now, where is the set? I think let's get this task. Okay, so whatever we had, sorry, thread demo we had, let's get these two runnables that we had. Now what I'm gonna do is, I'm gonna use, okay, I'm gonna use executor service equals to single new single thread executor. All right. Now what I'm gonna do is, I'm gonna submit them. What are the tasks I'm gonna submit? So this is where I will start submitting. Service dot execute, let's say print new records, print or let's say I did that again. Now let's say we did it again. All right. Let's run this. See what all happened. See what all happened. What happened? This begin and end just submitted the runnables. And after that, it started execution. So service, again, it is a single thread executor. So what it will ensure? The first task that is submitted will get executed, then the next task, and then the next task. If I change the sequence, you will see that the order will change. And this guarantees, because it's a single thread, it guarantees you the sequencing. See, I've just done the printing inventory, and then first, this is what print inventory, then the print records, then the print inventory, and then print records, and then right, this was the printed okay, before, because all these threads would have been running in, right, in parallel to the main thread. Okay, so what we are saying is this is how single thread executor works. Now, one thing that to note here is we are using in the try with resources. This syntax is try with resources. We are using something, some statement within the try. And what's the significance of it? Let's take a look at it. The contract says that try with resources can only be used for something which is auto closable. Something which is auto closable only can be used with try with resources. And that's why it is ensuring that once try block is completing here, they will go and mark that as a close, and close will actually go and do the, I would say, cleanup of all the threads that were created as part of the factory method that was used here. All right. Is everyone clear with this? Is everyone clear with this? Is everyone clear with this? Now, I wanted to show you something. Okay. I wanted to show you something. That is, take a look at here. I'm going to debug this program. I'm going to debug this program. Now, F8. Now let's take a look at this. What all we have? We have something like, so this is the executor service. I'm trying to show you how exactly its internal structure is. So executor service contains some sort of a queue. And in this case, if you see, the queue size is 3 because I have submitted only 3 tasks. I have submitted 4 tasks. Maybe one task would have been completed. We'll see that. We'll see that one task would have been completed or it would have been with somewhere. Okay. So now if you see, I have submitted 4 tasks, but there are 3 tasks that is in the queue, and there is a worker who actually executes your tasks. So with worker, there is one task that is added, and you go and see that which task that worker has. You go and see that which task the worker has. All right. So this is the thread. This is the name. Where is that task? I wanted to show you the task. The first task is okay. It hasn't completed yet, so I'm gonna show you. So it's pointing to this. So this is again back. Now, exclusive owner thread is gonna be your pool one. So somewhere this should be having your task that you wanted to execute. Somewhere it should be mentioning. Let me go and change that and check that for you. So pool one thread one. Okay. Now pool one thread one is, where is that finalizer GVM pool one thread one, right? So pool one thread one should be having the task, or because I did not add any breakpoint, let me add that breakpoint. Actually, that will help us a lot more easier. So let me go and add a breakpoint to this, add a breakpoint to these runnables as well. Now let me go and run these again, debug this again. What I'm gonna do, I have got my executor service created. Go and check that. And if you see the executor service, the worker queue size is 0 and there is no task that is active. Okay, so there is no task that is with the worker. Okay, so both of them are 0. Now I will put 1 because it just has only one thread, only one worker. What will happen? It will go and put that into the workers part. Correct? The next execute that I'll go and submit, what will happen? It will go and add it to the worker queue, and all other tasks that you keep on adding, they will get added to the worker queue. Now you see all 4 out of all 4, first three have been submitted to the worker queue, right? First one has been submitted to the workers, and next three has been submitted to the worker queue. Now, what will happen as and when, where is that? I should have got this one as well. Oh, okay. Lambda block, you may not get. So, okay. So by some means, I should be getting the control of it. By some means, I should be getting the control of it. And for some reason, where is that? Disconnected from the target. That's completely okay. So for some reason, we are not getting the breakpoints here, but the whole crux is that always the number of thread pool. So imagine I just change the thread pool size as new fixed thread pool, new fixed thread pool of size 2. What will happen? Two of them will go to worker, and then remaining two will remain with the queue. Let's see that. Now let's see this. What will happen? 2 is with the worker and 2 is with the worker queue. All right. And this is how right things work with the thread pool. Okay. Now what will happen if I go and hit next? I'll go and resume. It will go and execute all the statements that was added before. All right. Anybody has any questions so far?